This is the answer to a facetious Fermi question. Enrico Fermi was noted for asking his students difficult questions that required thinking about a problem in a way that would help simplify it. This is not quite like a Fermi question, but it does teach us how to use conversion factors. And the question is, if you point your finger at the Andromeda galaxy, which is 2 million light years distant, how long will it take your fingernail, growing at 1 millimeter per week, to reach it? To solve this problem, you need to know that rate times time equals distance. You're also asked to give your answer in moles of years, and you also need to know the speed of light, which is 2.99 times 10 to the 8 meters per second. The problem can be solved in about 5 steps. The first is to calculate the distance in meters. Now, it doesn't have to be meters. I just chose to use meters. I could have used millimeters or centimeters, as long as the units equate. And the reason being, I want to plug in values in the rate times time equals distance. I've been given the rate of growth of a fingernail, and I've been given the distance to the galaxy. So it's only a question of getting the right units to equate, so I can find the amount of time that it takes. So we calculate the distance in meters. First of all, there's 2 million light years. There's 365 days a year. And a light year is a measure of distance. It's the amount of distance covered by a beam of light in 1 year. So we have to find what that is in meters. And then we'll multiply by 2 million, because that's how many light years distance the Andromeda galaxy is. So 2 million light years times 365 days a year times 24 hours a day times 3,600 seconds per hour times the speed of light in meters per second. When you cancel all the units that can be canceled, you'll find that you're left with the distance to the Andromeda galaxy in meters. And here it is, 1.89 times 10 to the 22 meters. The next step is to calculate the rate of nail growth in meters per second. Since we have the distance in meters, let's find the rate of growth of a fingernail in meters per second. It grows 1 millimeter per week. There are 7 days in a week, 24 hours a day, 3,600 seconds an hour, and 1,000 millimeters per meter. So millimeters cancel, weeks cancel, days cancel, hours cancel, seconds don't cancel, and meters don't cancel. So we say 1 divided by 7 divided by 24 divided by 3,600 divided by 1,000 in our calculator. The final result is that a fingernail grows at 1.65 times 10 to the negative 9 meters per second. Now that we've got a distance and a rate, we can plug them into the rate equation. Rate times time equals distance. We solve for t. Two numbers, one divided by the other, gives you that it'll take the fingernail 1.14 times 10 to the 31 seconds to reach the Andromeda galaxy. Then we convert seconds back to years. 1.14 times 10 to the 31 seconds divided 3,600 seconds per hour, divided 24 hours per day, divided 365 days per year, will give us an answer in years. 3.62 times 10 to the 23 years, but our question asked us to answer in moles of years. So we divide by Avogadro's number. This number divided by 6.02 times 10 to the 23, it takes 0.602 moles of years. We're only allowed 2 significant figures, so the final answer is 0.6 moles of years for your fingernail to grow all the way to the Andromeda galaxy.